The year is 1983. A dusty red horizon stretches endlessly beneath a pale, salmon-colored sky. The sun appears smaller here, dimmer and distant, casting a strange, quiet light across an alien world. And standing on that surface is a human being. Not a robot, not a machine, but a person. An astronaut in a bulky white suit presses a boot into the Martian soil, leaving behind the first footprint ever made on another planet. And the strange part is, in another version of history, this already happened. Not in the distant future, and not in science fiction, but as part of a real plan that could have placed humans on Mars as early as the 1980s. Back in the 1960s, while the world was focused on the race to the moon, something far more ambitious was already taking shape behind the scenes. To NASA's engineers and scientists, the moon was never the final destination. It was a stepping stone. The real objective, the true prize, was Mars. And at the height of the space race, reaching the red planet didn't feel like a wild dream. It felt like the next logical step. There was a genuine belief that if humanity could land on the moon, then reaching Mars was not a question of if, but when. NASA's thinking at the time wasn't small or cautious. They were designing entire systems for space travel, permanent stations in orbit, reusable spacecraft, and massive interplanetary vehicles assembled piece by piece above Earth. The Saturn V rocket had already proven that enormous payloads could be launched into space, and many believed it was just the beginning. Engineers weren't guessing about Mars missions, they were calculating them, designing them, and refining them with serious intent. One of the most detailed proposals came in 1968, when aerospace engineers outlined a mission that, even today, sounds incredibly bold. The plan involved constructing a massive spacecraft in Earth orbit using multiple launches of the Saturn V. This wasn't a single rocket mission, it was a coordinated effort requiring several launches just to assemble one interplanetary vehicle. The spacecraft would carry a crew of 6 astronauts and rely on nuclear thermal propulsion, a technology that promised far greater efficiency than traditional chemical rockets. Instead of burning fuel in the usual way, a nuclear thermal rocket would use a reactor to superheat liquid hydrogen, turning it into a high-speed exhaust that could propel the spacecraft much more efficiently across vast distances. This would significantly reduce travel time, bringing a trip to Mars down to roughly 6 months. For NASA at the time, this was considered manageable. They had already begun solving the challenges of long-duration spaceflight, including food storage, water recycling, and the psychological effects of isolation. Once the spacecraft reached Mars, 3 astronauts would transfer into a dedicated landing module and descend toward the surface. Using a combination of parachutes and rocket engines, they would slow their descent through the thin Martian atmosphere before touching down on the surface. This approach, remarkably, is similar to how modern Mars missions operate today, except those missions are robotic. In this plan, it would have been humans making that descent. The astronauts wouldn't just land and leave. They were expected to spend around 30 days on Mars, conducting experiments, collecting samples, and exploring an environment that, at the time, was still largely a mystery. They didn't fully understand what they would find. There was speculation about water, about possible life, even about remnants of ancient ecosystems. Every step they took would have been a step into the unknown. After completing their mission, the crew would launch from the Martian surface in an ascent module, rejoining the main spacecraft waiting in orbit. From there, they would begin the long journey back to Earth, eventually re-entering the atmosphere and splashing down in the ocean, just like Apollo astronauts before them. It was an incredibly complex mission, but it was grounded in real engineering and real technology. Nothing about it violated the laws of physics. In fact, much of it was entirely achievable with the tools available at the time. So why didn't it happen? If the plans were real, and the technology was within reach, what stopped humanity from taking that next step? The answer lies not in engineering, but in circumstances. By the early 1970s, the momentum that had driven the Apollo program began to fade. Political priorities shifted. The Vietnam War consumed resources and attention. Public interest in space exploration declined after the initial excitement of landing on the Moon wore off. NASA's budget was reduced, and with it, the possibility of pursuing something as ambitious as a mission to Mars. At a critical moment, the United States faced a choice. Continue pushing outward toward Mars, or invest in a more sustainable, Earth-focused space program. The decision ultimately favored the development of the Space Shuttle, a reusable vehicle designed to make access to orbit more routine and affordable. It was a practical choice, but it came at a cost. The grand vision of interplanetary travel was postponed, and the mission to Mars was set aside indefinitely. And so, the first human footprint on Mars never happened, not because it couldn't, but because the world chose a different path. But the question still lingers. What if that choice had gone the other way? What if the funding had remained, the vision had persisted, and the mission had moved forward? Today, Mars might not be a distant goal. It might be a place we've already been, studied, and perhaps even begun to inhabit. Instead, it remains just out of reach, a reminder of how close we once came to changing the course of human history. If NASA had committed to Mars in the early 1970s, the decade that followed would have looked nothing like the one we know today. Instead of winding down after Apollo, the space program would have accelerated into its most ambitious phase yet. Massive infrastructure projects would begin in Earth orbit, far beyond anything ever attempted before. Space would no longer be a place we visited occasionally. It would become a place where we worked, built, and prepared for something much bigger. The first step wouldn't be Mars itself, but the creation of a permanent presence in low Earth orbit. Using modified Saturn V rockets, NASA would launch components for large space stations, structures designed not just for research, but for construction. These stations would act as shipyards in space, where astronauts and engineers could assemble the interplanetary vehicles piece by piece. It was a completely different philosophy from Apollo. Instead of launching everything at once, they would build the mission gradually, carefully, and with precision. Living and working in orbit for extended periods would force NASA to solve problems that had only begun to surface during the Gemini and Apollo missions. Microgravity, for example, posed serious risks to the human body. Astronauts lost muscle mass, bone density, and cardiovascular strength the longer they stayed in space. To counter this, some designs proposed rotating sections of space stations or spacecraft to simulate artificial gravity. These spinning habitats would create a gentle centrifugal force, allowing astronauts to live in conditions that felt closer to Earth. It was an elegant solution, though technically challenging, and it showed just how far ahead engineers were thinking. At the same time, life support systems would need to evolve rapidly. A mission to Mars wasn't a matter of days, it was a journey lasting years. That meant recycling air, water, and even waste with near-perfect efficiency. Closed-loop systems, where nothing is wasted and everything is reused, would become essential. These technologies were already being studied, but a Mars mission would push them to their limits. In many ways, the challenge wasn't just reaching Mars, it was learning how to survive the journey there and back. Then there was the spacecraft itself. Unlike the relatively compact Apollo capsules, the Mars vehicle would be enormous, a true deep space ship. It would need living quarters, storage, radiation shielding, propulsion systems, and a dedicated landing module, all integrated into a single structure. As assembly progressed in orbit, astronauts would essentially be building humanity's first interplanetary vessel by hand, conducting spacewalks to connect massive components drifting silently above Earth. One of the biggest concerns during this phase would be radiation. Beyond Earth's protective magnetic field, astronauts would be exposed to cosmic rays and solar radiation at levels far higher than anything experienced in low Earth orbit. Engineers proposed several solutions, including lining parts of the spacecraft with water or fuel tanks to act as shielding. Some designs even suggested a storm shelter, where the crew could take refuge during solar flares. These weren't perfect solutions, but they reflected a growing understanding of the dangers of deep space. As the spacecraft neared completion, training for the mission would intensify. The astronauts selected for Mars wouldn't just be pilots, they would be scientists, engineers, and explorers all in one. They would need to handle complex systems, conduct experiments, and respond to emergencies with no immediate help from Earth. Communication delays alone would make real-time guidance impossible. By the time a message reached Earth and a response came back, it could take up to 40 minutes. That meant the crew had to be completely self-reliant. Finally, after years of preparation, the moment would arrive. The launch window to Mars only opens every 26 months, when Earth and Mars align in a way that allows for the most efficient trajectory. Missing that window would mean delaying the mission by more than 2 years. There would be no room for error. Every system would need to function perfectly. Every calculation would need to be exact. When the countdown reached 0, the assembled spacecraft, now fully fueled and crewed, would ignite its engines in orbit, slowly pulling away from Earth. Unlike the explosive launches from the ground, this departure would feel almost quiet, a steady and deliberate acceleration into the void. Earth would begin to shrink in the distance, its blue oceans and white clouds fading into a small, bright sphere. For the crew, it would mark the point of no return. The journey to Mars would not be fast, and it would not be easy. For months, the spacecraft would drift through deep space, following a precise trajectory calculated years in advance. There would be no turning back, no emergency return, no rescue missions waiting in the wings. Once they left Earth orbit, the crew would be completely on their own. Every system, every decision, every small mistake would carry weight in a way no previous mission ever had. Inside the spacecraft, life would settle into a strange kind of routine. Days would be carefully structured to maintain both physical and mental stability. Exercise would be mandatory, not optional, as astronauts fought to preserve their muscles and bones in the low-gravity environment. Equipment would need constant monitoring. Filters cleaned. Systems checked and rechecked. Even the smallest mechanical failure, if ignored, could become life-threatening over time. But the physical challenges were only part of the story. The psychological strain of the mission would be just as intense. Imagine looking out of a window and seeing nothing but darkness, broken only by distant stars that never seem to get closer. Imagine knowing that Earth, the only home you've ever known, is now just a tiny dot behind you, too far away to help. Communication with mission control would be delayed, sometimes by as much as 20 minutes each way. Conversations wouldn't feel like conversations anymore. They would feel like messages sent into the past. Isolation would become a constant companion. The same small group of people, the same confined environment, the same unchanging surroundings for months on end. NASA had studied group dynamics extensively, but no simulation on Earth could fully replicate this kind of distance and disconnection. Tension would be inevitable. Small disagreements could grow into serious conflicts if not carefully managed. The success of the mission would depend as much on the crew's ability to work together as it would on the spacecraft itself. Outside the ship, the environment was even less forgiving. Invisible radiation would pass through the hull, a steady reminder of how exposed they truly were. Solar flares could erupt without warning, forcing the crew to retreat into shielded sections of the spacecraft. Micrometeoroids, tiny fragments of rock traveling at extreme speeds, could strike the ship at any time. Space, despite its emptiness, was far from safe. And yet, despite all of this, there would be moments of awe. Moments that no human had ever experienced before. The crew would watch as Earth and the Moon slowly disappeared from view, replaced by a sky that looked subtly different from anything seen from home. Stars would appear sharper, more numerous, untouched by atmosphere. The sun, no longer filtered through Earth's skies, would shine with a harsher, more direct light. As weeks turned into months, something remarkable would begin to happen. Mars would stop being just a bright point in the distance. It would grow, slowly at first, then more noticeably with each passing day. A faint reddish hue would become visible, then surface features, then polar caps. For the first time in human history, a group of people would watch another planet transform from a distant object into a real, tangible world hanging in front of them. The approach to Mars would be one of the most critical phases of the entire mission. Timing had to be exact. Speed had to be reduced at precisely the right moment. The spacecraft would rotate, engines firing in the opposite direction of travel in a long, controlled burn designed to slow it down just enough to be captured by Mars' gravity. Too much thrust, and they risk missing the planet entirely. Too little, and they could enter an unstable orbit, or worse. If everything went according to plan, the spacecraft would settle into orbit around Mars, circling the planet high above its surface. From this vantage point, the crew would see a world unlike any they had ever known. Vast deserts of red dust. Deep canyons stretching for thousands of miles. Massive volcanoes rising higher than anything on Earth. And beneath it all, the lingering question that had driven decades of exploration: could this planet have once supported life? The descent to Mars would begin in silence, as 3 astronauts sealed themselves inside the landing module and separated from the main spacecraft orbiting high above the planet, leaving the rest of the crew behind with nothing to do but wait and trust that everything would go according to plan, because there would be no second chances and no rescue if something went wrong. As the lander drifted closer, it would fire its engines to begin the descent, and slowly the Martian atmosphere would take hold, a faint glow building around the craft as it slammed into the thin layers of gas at incredible speed, shaking violently while still not providing enough drag to slow it safely, forcing the deployment of a massive parachute that would help but not nearly enough, until finally, in the last critical moments, the engines would ignite again in a controlled landing burn, kicking up a storm of red dust as the spacecraft touched down and came to a complete stop on the surface of another world. Inside, there would be a brief pause as the crew checked their systems and processed the reality of what they had just done, before preparing their suits, cycling the airlock, and opening the hatch, stepping out one by one onto the Martian surface where each movement felt lighter yet unfamiliar, their boots pressing into soil that had remained untouched for millions of years, marking the beginning of humanity's first presence on another planet. Over the next 30 days they would conduct experiments, collect samples, and explore the harsh, silent landscape, all while aware that Earth was now just a distant point in the sky, a realization that would reshape their perspective forever. And when the time came to leave, they would launch from the surface in the ascent module, leaving part of their lander behind as a permanent marker of their visit, rejoining the main spacecraft in orbit before beginning the long journey home, carrying with them not just data and discoveries, but the experience of having stood on Mars. And months later, as Earth grew larger once again, they would re-enter the atmosphere in a fiery descent before parachutes deployed and the capsule splashed down safely in the ocean, marking the return of the first humans to ever walk on another planet. An achievement that could have changed history, yet remains one of the greatest what-ifs of all time.